Okay, we're back. We're going to get that number 10. In this case, we're going to need our solubility chart, or you're going to need to know your solubility rules. And I have silver nitrate. You're going to assume one of the things is you have to be able to write formulas, and that you can do that. Silver nitrate, +1, -1 between those two ions. Calcium's a +2, chloride's a -1, so we cross charges. It's going to be net ionic equation are always double replacement reactions, so the +2 is going to go with the -1 here, and then the +1 is going to go with the -1 here. And now we have to go look these two chemicals up. If you remember your solubility rules, nitrates are always soluble, so this has to be AQ. And if you look up silver chloride, the rule for chlorides is all chlorides are soluble except mercury, silver, and lead. So this is our precipitate. So the ions that form this, easy way to do this, the ions that form this are the net ionic equation. So silver makes +1 ions, aqueous. Chloride makes -1 ions, aqueous. And they make solid silver chloride. Now this one was easy because this was a +1 and a -1. You may have needed more than one of each of the ions in the original if these had not been balanced. So that's there you go. That's all you got to do for net ionic equations. Various parts of a chemical reaction, symbols for each. In those cases, the plus on the left side means reacts with. On the right side of the equation, it simply just means and. Arrow, yields, produces, makes, forms. Delta sign, the delta sign is heat. How to show energy or light added. Energy, you can just write an E. You can write an H nu for a frequency, which is energy. H times nu is Planck's constant. How do you show a catalyst? Write the name of the chemical above the arrow. In our mole rocket lab, we used that black powder that was manganese dioxide. So in that reaction, we took hydrogen peroxide. We added manganese dioxide as a catalyst, and it broke down into water and oxygen gas. And that's where you got your oxygen from. And that could be reused. So catalyst, how does it work? It works by lowering the activation energy. Lowering the activation energy. And it does not get consumed in the reaction. So that's why the black powder, you didn't have to keep adding it because you could reuse it. Balancing equations, let's see. Wow, we got 3 O's here, 2 here. So if we did a 3 and a 2 to get 6, I don't know, maybe. If we did a 2 and a 2, then that would give us 2, 2, 2, 2, 2, 2, and 4, 6. And there it is, there's our 6. 5 type chemical reactions. We have the synthesis. Let's go to just like a blank page here. We have the synthesis. We have the decomposition. We have the single replacement. We have the double replacement. And we have the combustion. This is C something, H something plus oxygen makes CO2 and H2O. Here we have AB plus CD makes AD plus CB. A plus BC makes AC plus B. AB turns into A plus B. A plus B makes AB. Now remember, they're not always this easy. You can't just shove them together. You have to put the charges together in all cases. They're going to ask you to predict the products of some reaction and write the correct formula for it. So that's going to be the type of a question you get along with that. Like if you just saw aluminum plus oxygen, well, you might, I guarantee you, one of the choices is going to be that, and it's not right. Aluminum forms positive 3 ions, oxygen negative 2, cross the charges. It makes Al2O3. Remember, on the single replacement, you may have a metal that's below another metal on the activity series, and it may be a no reaction in that case. So remember those. That's another possibility. Of course, you're going to look at some reactions and just have to identify them. Here's one where two chemicals went together and made one. That would be a synthesis reaction. Molarity problem. What's the molarity of substance if 2.5 moles are dissolved in 5 liters? Molarity is moles over volume. So we take 2.5 moles, we divide by 5 liters, and we would get 0.50 moles per liter, or 0.5 moles per liter. What are the typical products of combustion reaction? We had that earlier, CO2 and H2O. You can also get CO if it's incomplete. What things are conserved in a chemical change? We said there was always two things that have to remain the same: mass and the number of atoms. That's the law of conservation of matter. What's a mole ratio, and use it to convert between two substances in a stoichiometric? It says number 14 up here. I think they meant number 15. What is the mole ratio between aluminum and iodine? Well, aluminum and iodine, 2 aluminums for every 3 iodines. So you could either say that 2Al over 3I2, or you could say 3I2 over 2Al. Since it said aluminum and iodine, we assume they meant this. How many moles of iodine would be needed to react with 2.85 moles of aluminum? That's a nice stoichiometry problem. Remember, it was 2Al plus 3I2 made 2AlI3. So in that case, we know that we have 2.85 moles of aluminum. And they want to know how many moles of iodine. So the ratio is 3 to 2. One-step problem. And 3/2 of 2.85. Big storm rolling in here as I'm working on these. 4.3. Yeah, 4.3. 4.28 moles. Do volume gas stoichiometry problems. Remember, a volume gas stoichiometry problem under STP condition works just like a mole problem. So you should be able to work this one just like you work this one. So 34 liters of ammonia multiplied by, it says, would produce how many liters of water vapor. So the water vapor here is in a 1 to 2 ratio with the ammonia. So half of that would be 17 liters of H2O. Thanks for the input. Good luck on your final. You should have all the videos now on all the topics. If you need to come by and see me, I get here at about 6:45 in the mornings, and the door will be unlocked on the teacher's parking lot side. Talk to you then. Bye.